In this video, we're going to be taking a look at compound interest, which is a cool application of the exponential growth model. It's a very kind of complex type of an equation that has a few different parts to it. So I kind of color-coded the different parts for you. In that blue box is the formula that you will need to know, at least in short-term memory, for this chapter. So I'm just going to kind of talk to and speak to each of the different parts. The final amount I have in white, that's kind of the amount A. In pink is the principal, that's going to be your starting amount of money that you're going to invest. R is your interest rate that you're given for your investment, and N is kind of interesting. It's the number of times that you're compounding your interest per year. So in general, the more that it's compounded, the more money you're going to get, but we'll find out something kind of interesting later on in a different lesson that the more you compound, you may not get just more and more money necessarily. So we'll keep that in mind. T is just the time in years of your investment. So what I'm going to try to do with you guys, and make sure you have all this written down, is apply that formula to the following example. And then, of course, you'll try one on your own. Example 1 says you deposit $4,000 in an account that pays 2.92% annual interest. Your job is to find the balance after 1 year if it's compounded quarterly and daily for part B. So, how I like to do these problems is I'll start off by plugging in all of the numbers where they belong into the formula. So I know the formula, and it's actually probably a very good idea if you just start off by kind of writing your formula. A equals P times 1 plus R over N to the NT power until you at least have it memorized. So I would start by doing that each time you have these problems. So let's begin with the principal. The principal is my starting amount, so I think it was at the beginning. This number right there, that $4,000, is my starting amount. That's the deposit. So I'm going to put 4,000 out in front. Then in parentheses, it's going to be 1 plus. Now my interest rate is this percentage. Now, one thing that I should note here, and let's write it over here, you always want to write your interest rate as a decimal, not as a percent. So what that means is I'm going to have to convert this percent into a decimal, and that's simply done by dividing by 100 or just moving the decimal place over twice. So if I did that, it'd be 0.0292. That's really our 2.92% as a decimal. So it's going to be 0.0292 over there. All of that's got to be divided by n. N is how many times we're compounding. Now for A, part A, my value for n, how many times I'm going to compound, is quarterly. Guys, a quarter, there's 4 to a dollar, there's 4 quarters in a football game, or really any game, so n just is 4 for this example. We're going to compound 4 times per year. So that number 4 goes in the denominator there. It also is going to be part of my exponents to the power n times t. Now, t is how long we're doing our investment, and in this case, it does say right here, we're investing for 1 year, so I'm going to put a 1 up there. Now, if it's possible, before I grab my calculator, I try to clean up a little bit, and there's really not a lot for me to clean up here before I grab my calculator, but I will say I'm going to do this. I'm going to write this as 4,000 times 1 plus 0.0292 over 4, and instead of the 4 times 1 power, how about let's just write that as 4. Now I'm going to pull up the calculator in a second, and I'm pretty sure when I go back to the screen, everything is going to be wiped out. So make sure you have this written down, or I guess if you don't, you can always rewind, right? So I'm going to switch now. Now I'm in Desmos, and what I'm going to do is I'll show you 2 ways of doing this. I'm going to type in the whole amount, that whole equation first. I'm going to put in 4,000, and then in parentheses we're going to do 1 plus, oops, not 1 divided by, oops, 1 plus the quotient of 0.0292 divided by 4. Ooh, that's kind of cool. It looks like an actual exponent. Now this whole thing is supposed to be raised to the power 4. So I think I've just typed that in exactly as it needed to be. If I hit enter, I get that final amount. As you can see, the final amount is $4,118.09. Now remember, anytime there's a money problem, we usually just go to the nearest penny, which is the hundredth, right? Second decimal place. Now, the only thing that changes with part B of that problem, if you recall, is it's compounded daily. So the principal is still 4,000. So if I'm going to do this one, I'm going to still type 4,000. And then in my parentheses is going to be 1 plus, and I still have the same interest rate of 0.0292. And I'm going to divide that by, now it's daily, so I'm compounding every single day of the year. So interest is being earned every single day. That's 365 days out of the year. And now I'm going to move my cursor to the outside and raise it to the power of the exponent. Now I have to be careful. Remember, it's n times t. My n value is 360. Oops, not 335. It's 365, and I'm still doing it for 1 year. So I'm going to write that in there just to show you. I'm really doing to the power n times t. And if you hit enter, you'll see the amount doesn't change by a whole lot. It's $118,000 still, and only 52 cents. So it's interesting. If I compound quarterly, I still had $4,118.09. By compounding every single day and earning interest every single day, I'm only making, 41 cents more or so. Or 43 cents rather. So it really did make that big of a difference. I'm going to go back to the screen. Okay, so just to kind of summarize what we just did for part A, this is really what I typed into Desmos and gave me the answer of $4,118.09. This is what we plugged into Desmos for part B if we were compounding 365 days a year daily. And this is the answer it gave me. What I'd like you guys to try right now is the following. Let's say you deposit $2,000 in an account that pays 4% annual interest, and I want you to find the balance after 3 years, not 1 year anymore for this problem. It's going to be for 3 years if you compound monthly for part A, and for part B if you compound daily. So see if you can work those out. At least what you should show for this is at minimum like this type of work. Show what you are plugging into Desmos, and then let Desmos do all the work, and you can write down that final answer, and we'll go over it tomorrow. Thanks for watching.